Okay, this is problem 3 and 6-4. Very much like the problem 2 was, except you're given a base of 3 here. So this is the basic graph of y equals log base 3x. Here's the point 1, 0. Your vertical asymptote is x equals 0. The domain is 0 to infinity. The range is negative infinity to positive infinity, and the vertical asymptote is x equals 0. Now, for our specific problem, we're changing it to f of x equals 3, so everything's going to be shifted up 3, plus log base 3x plus 1. It's going to be shifted to the left 1, so we're going to go up 3 and left 1, or left 1 and up 3 with this. First thing is the domain. Remember, we can't find the logarithm of a negative number. Actually, it has to be a positive number. It's to be greater than 0, not even 0. So x has to be greater than negative 1. Domain is negative 1 to infinity. Graphing it, put it in Desmos. It's the original left 1 and 3 up. And your answer choice there was C. This is what it looks like. The point that was originally 1, 0 became 0, 3 because you went left 1. That took the 1 that was the x and made it a 0, and the y was originally 0. It went to 3. Okay, the next thing they're asking for is the range and the vertical asymptote. So looking at the graph makes it a little easier to do that. The range, what's happening? Range-wise, it's going on down, down, down for y's, and this will keep going, just not really fast in that direction. So your range of the original was all real numbers. None of the translations are going to change that, so the range will stay all real numbers, or negative infinity to positive infinity. The vertical asymptote was originally x equals 0, but with the shift it became x equals negative 1. Now, finding the inverse, we go through the same process we did previously. First thing, change f of x to y. Second thing, interchange the x and the y. Now begin solving for y. Move the 3 over. Okay, and then you have a logarithm. Still have a logarithm. The next step needs to be to get rid of the logarithm. So we take this base of 3, we put it right here, and this side becomes its exponent. This whole x minus 3 is the exponent, and then it's going to equal the y plus 1. We want y right by itself, so we're going to move the plus 1 over, make it a negative 1. Once you have that done, you replace y with the inverse notation, f inverse of x. Domain and range, of course, remember they just flip around. Your domain is going to be all real numbers, which was the range of f of x. The range is negative 1 to infinity, which was the domain of the original f of x. The graph of the inverse looks like this, where you had the point 0, 3, now you've got the point 3, 0. You've got, instead of the asymptote being vertical over here, instead of being x equals 1, it's horizontal right here at y equals 1. This is the graph of the two together. The logarithm looks like this, kind of turning over, and the blue is the exponential. So we've got an exponential and a logarithm with both of their asymptotes, and I also put in the line y equals x. It's dotted this time. I hope that all makes good sense to you. It's a very important concept. I almost feel like if you can do these problems right in here, then you pretty much have exponentials and logarithms pretty well under control.